So welcome. My name is Liz.
And I'm Charlie.
And we're members of the NRICH team here in Cambridge. We're delighted to welcome you to this afternoon's webinar. Today we're focusing on resourcefulness. So far we have completed a series of 5 webinars which are focused on mathematical thinking skills, and now we've turned our attention to mathematical mindsets. You may have joined us for our previous webinar, which was on curiosity, and here we are thinking about resourcefulness. In a moment, we're going to share the NRICH website, and please be reassured that everything we draw upon in today's webinar, you will find in our written guidance on the NRICH website. We'll show you where to find that, so you shouldn't need to make too many notes. We'll come to that later on in the webinar. So, Charlie, quite often at NRICH, we refer to an article written by Alan Wigley. And in that article, he talks about a sort of 2 contrasting models of teaching and learning. The first one, which perhaps we might find most commonly in schools, he terms the path smoothing model. So he talks about teachers helping their students to make very, very sort of small steps so that they don't fail as they go along in their mathematics. And I think that's a natural thing to want to do, isn't it? To support your students along the way so they don't make mistakes, they don't fall down pits, as it were. But that makes students very dependent on the teacher and very dependent on particular ways of working which the teacher might have shared with them. So by contrast, Alan Wigley talks about, he terms it the challenging model. So he then suggests that actually we should start our mathematics lessons with a problem. We invite students to share their ideas, to talk to each other about what they think they could do. And then as a teacher, we are valuing all students' contributions, and we're helping to build on them. And I guess in that way, we're much more likely to create resourceful learners who have got a number of different tools at their fingertips and can draw on them in the future. And I think it's that challenging model that at NRICH we would advocate, and that's what we're going to base this afternoon's webinar on. Would you like to add any more? What have I forgotten there?
Okay. I mean, it seems quite natural as a teacher to want to offer students a path smoothing model.
It does.
Because you want to make it as unproblematic as possible for students.
Absolutely.
And I think when I started teaching, I thought, it is what I aimed to do. But
me too.
There's a challenge. The problem is students become really dependent on me showing them how to do things. To be a good mathematician then just requires them to pay attention and imitate what I've done.
Yeah.
Whereas the challenging model, I think, is much more optimistic about what students can do,
what they can bring
to an activity. Yeah. And if students have lots of experience of tackling problems and the teacher trusting that they can tackle the problems and use their capabilities, that they can use their ideas, make connections, be creative, then at the end of the day, I think students leave those classrooms feeling that they are used to behaving and thinking like mathematicians, that there are many more ways of being successful than just by paying attention.
That's right. Yeah. Okay. So what we hope to do is to offer you a range of tasks which will suit your learners, learners in the primary setting, And as we go through, we'll draw out some of the ways in which you as teachers can structure your classrooms, to think about the way you facilitate in order to encourage students to become more resourceful. So we're going to do all that by working on some tasks together. Now, before we go any further, I think it's really important to say that we have picked a range of tasks to look at now, but of course the NRICH website, it offers you activities suitable for children from the age of 3 upwards. So just because the tasks that we work on in this, next sort of 45 minutes or so happen to be pitched at particular age groups, you will be able to apply the same principles to a whole range of tasks, and we'll show you where to find tasks nearer the end of the webinar. Okay, are we ready to get going on a first task, Charlie? So this first one, we will, we're going to, somebody has just asked about the name of the person that we mentioned. We're talking about Alan Wigley. And thank you, somebody else has already linked to the article, one step ahead of us.
And we have linked to the article in the guidance as well.
We have. Thank you very much. Thank you.
We'll make sure that everything we mentioned is included in the guidance. And even if it's not there today, it will be there by the end of the day tomorrow.
Absolutely, yes. So the first task we're going to have a little go at with you is just a quick task that it's not on the NRICH website, but this is to show you what you can do relatively easily in the classroom. So Charlie, let's imagine that we're going to be working out the calculation 14 times 12. Now, one way of approaching that would be, as a teacher, I could have demonstrated a particular way of calculating, and then what I might do is I might offer 14 times 12 as an example that students could work on to practice that method. But instead, what we'd like you to do is think about 14 times 12. How would you go about working that out? So if we could give you a moment or two, pop your suggestions in the chat, please.
And this is to mimic the kind of question you could ask students. How would you, we could ask the student, exactly, how could you work out 14 times 12? Is there more than one way of working out 14 times 12?
Which is, yes, so, giving students so much more choice compared with, here's the model, now have a go. So over to you. How would you work out 14 times 12? Thank you very much for the suggestions that have come in. Now, of course, we're going to gloss over this, not gloss over, we're going to go fairly quickly, but in the classroom, we would be gathering these suggestions, and then we'd be inviting children to explain how they would do it, making sure everybody else is following the method. And that's, at that point, this is your role then, is to step back, invite students to question each other and clarify methods. So I can see, Charlie, we've got quite a number of people have used a sort of a partitioning approach. So they've taken, for example, the 10 and the 12, and they've broken that down into 10 and 2, and they can work very easily with 10 and 2 as multiples of 14 and done that. Alternatively, some people have partitioned the 14. I think. Yes. Somebody else used a slightly different approach and went from a sort of a known fact. I know 12 times 12 is 144. So this means I can go from 144 to add on another 2 12s and get the result that way. Yeah. And
there was, yes, a 7 times 12 and then
yes,
double that.
You're right. Yes.
So, yes.
Yeah.
It seems to me that students who are in a classroom which discuss this variety of approaches are much more likely in the long run to be capable of being resourceful when they're in a new situation than those who've only learned one method and think that this is the only method, or that this is the only acceptable method, or that this is the method the teacher requires.
Precisely. Okay, we're going to offer you a slightly, we're going to offer you a different task now. They're related in some ways. And I think for this, what we might do is share our, I don't know, shall we share a piece of paper and write down the calculation? Would that work?
Well, or you could write it in the chat.
I guess I could write it in the chat. Okay, maybe that's easier. So I'm going to write a subtraction calculation in the chat. 623 take away 478. And I'd like, and I also share that. There we go. And I'd like your challenge here is to offer some more subtraction calculations which have the same value as that one that we've just popped in the chat.
So instead of asking students to carry out this calculation, we're asking a slightly different question. What other subtractions would give the same answer?
Exactly.
Okay, we'll give everybody a minute or two.
A couple of minutes, yeah. How lovely, how lovely. I can imagine sort of in the classroom situation, depending on how much experience the children that you work with have had on questions like this, there may be a sort of an element of sort of, what's the word I'm looking for? Some curiosity as well, but sort of a puzzlement if you'd pose this kind of question. But I think once a couple of people offer a solution, it's interesting how it gets it kind of stimulates your own, it opens up the possibilities perhaps.
But also the realization that you can just carry on all day. I mean, there are an infinite number of possibilities rather than just one answer.
Absolutely. Absolutely. And wouldn't that be lovely if that came up as a conversation point?
And it can be so easy in a classroom where one person gets the answer and then you have to move on.
Right, the thinking stops.
Yes, there's only one answer to the question that's been asked, and once somebody has blurted it out, well, that's it.
Yes.
And I know some students who sometimes don't make an effort because they know somebody's going to get the answer sooner, so they just wait for that answer to be shouted out by somebody. Whereas here, everybody can come up with
contribute. Yeah, it's really nice. So a couple of you have actually explained what you've done, and I can guess at what others have done. So that, you know, adding, somebody said they added 22 to both numbers. I can see somebody has added 100 to both numbers. And of course, in the classroom, again, we would spend time here having the conversations about what students had done.
Interestingly, but I think students might, at some stage, somebody might realize, oh, you could do 1,623 minus 1,478. And then children getting quite excited. Oh, I could do 1,623 minus 1,470.
Yes.
You know, 42 million.
That's right.
And all that recognition that you can go really wild.
Yeah. And I guess, and this leads to some quite probing questions in the sense, you know, we could talk about, well, you know, why is it? How do I know that this is going to have the same solution as the original calculation? and I think here we then start to maybe draw on some representations, which we will come back to later in the webinar.
But also, when the students are talking about how they justify what they're doing, they're using strategies which are generalizable.
Yes.
They are not just solving one single subtraction.
That's
they are justifying what they're doing because of their understanding of place value or their understanding about what subtraction is all about. And they can be using images, metaphors about, well, if somebody's this age and somebody's that age, in a year's time, the difference between their ages is still going to be identical, for example.
Exactly.
So they can use their explanations are valid in this example and in many more.
And in many more, absolutely. So this moves us totally away from this kind of myth that maths is all about a right or wrong answer. Here we are focusing so much on the methods, the way of calculating, the way of working out, so we move away from that.
But also what's nice, for example, is somebody quite early on said that if they added 22 to both numbers, then the difference was going to be the same. And it was going to, and they ended up with 645 minus 500. And that then becomes a much easier subtraction.
Absolutely.
So if I do want to work out the answer to this, that is possibly a nice, efficient way of working out the answer.
Much less likely to make a mistake.
Much less likely, yes.
I can be confident I'm going to get the same result as the original question, but actually in this way, I'm much less likely to.
All I've had to do is add 22 to both sides, 2 to both numbers, which is not too difficult in this case.
Yeah.
And then subtracting 565 is fairly straightforward.
Yeah, good. Okay, so let's move on to another kind of another style, if you like, in the sense that, so if we've had lots of these kind of conversations where we're kind of being prepared to draw on different ways of thinking and bringing different skills to the table, I think something that a teacher might do then is offer some restriction. So what happens if actually we put in a constraint of some kind? So one way of doing that would be to have, what I'm going to do is I'm just going to share on my screen. Let me go to the NRICH website. And I'm going to share I know you can't see this yet, but I will be sharing in 1 moment. I'm just, okay, right. Back to Zoom and share. So I'm actually going to share it's actually an article rather than a task. But in this article, I'm going to scroll all the way down, and don't worry, we will put a sensible link to this. This article is describing what myself and a colleague did when we worked with a group of primary teachers over the course of a year in Haringey in North London. And so here on the screen now, I'm hoping that you can see, oh yeah, you're making it bigger, Charlie, yeah, thank you. Wonderful. This is what you might have come across before as a broken calculator task. So you're invited to look at the following calculations, and you have a calculator at your disposal. However, the number 6 is broken. So Charlie, shall we have a little think?
So all the questions have got 6s in them.
All the questions have got 6s in them, and so
so even though you have a calculator, you cannot do what you would normally expect it to do. So there is a need to be resourceful.
There is a need to be resourceful. So I wonder whether we've labelled the 6 with a, sorry, I don't know why I said 6, it's because we've got the number 6. We have labelled each calculation with a letter. So perhaps what we'd like to invite you to do is choose one and have a think about how you would approach that calculation on a calculator without the 6.
The 6 key doesn't work anymore.
The 6 key doesn't work anymore. And then perhaps in the chat, you could just identify the letter associated with the calculation you've tried and post what you would type in. So we'll give you a few minutes to do that. You know, once you've had a go at one, choose another one. Thank you very much for your contributions. I have to say, Charlie, when we looked at this earlier, we decided that D we possibly didn't need to do on the calculator at all, didn't we? But thank you for playing along with us. What a lovely task. It's interesting, isn't it? I think here that a lot of people have factorized where appropriate, where we've got some multiplication going on. And it's interesting, you know, the way I might factorize will be completely different to the way somebody else might factorize, depending on the knowledge at our fingertips, I guess, and our fluency in particular tables.
In the previous example, you talked about asking the students to justify or explain why they did what they did. And of course, another gambit from teachers would be to say, well, somebody wrote this. Can somebody try and explain what why they did this? Yes. Are we sure that it gives us the correct answer? How do we know? Yes. So it's not always the student who did it.
Who owned it, yes.
Everybody else has got some responsibility for making sense of what other people have done.
Yeah. Yes, that's a nice.
It might not be what they would have chosen to do, but can we make sense of it ourselves?
Right, good idea. Yeah.
Again, expecting students to understand and then to be able to explain what's going on, because that gives them the building blocks to adapt and use in other situations.
Exactly. And of course, you know, as you see, these calculations are, you know, some of them are very much up at Key Stage 2, but you can adapt this to all sorts of levels. Yes. We've got another similar broken calculator task.
I've also thought of something else teachers could. You can have lots of cards with lots of, and you've got these 10 questions or however many there are, and you have this collection of cards, and then you say, right, which of these methods was used? Can you pair them off?
Right.
So you've got, you know, what everyone's been writing in the chat, you make copies of them,
That's
you shuffle them.
Yeah, nice.
Can you work out what people were working out? Can you make a set of questions and answers yourselves and give them to your partner? It feels like it's like puzzled about it in quite an engaging way.
Yes.
So students are more motivated to work. If you give children, you know, these 10 questions, do I really have to do this? You know, I mean, why? You know, it's a little bit boring kind of thing.
Yeah.
So you're working on motivation, but also you are encouraging them, you know, to puzzle things, and usually puzzling involves thinking and not quite knowing what the best route to the solution is, but
that's right, and deepening their understanding.
Yes.
All right, shall we share this time we're going to share the visualizer, because we would like
so while Liz is sorting that out,
why don't
I'll
you
talk. Okay, so we've got another broken calculator activity, and we're hoping this is going to work. Oh yes,
yeah, it works, but it's slightly skew it.
Yes. I'll take my notes out of the way. So in this case, you, rather than the 6 not working, we only have 4 keys that work. The 4, the 5, the subtraction key and the multiplication key are the only keys that work.
We do have equals as well, but you know.
Okay, I will add equals.
And I guess we could say
and cancel.
And we've also got a cancel.
Yes.
That might be useful. But yes, I mean, though.
Yeah. Okay.
Brilliant.
And the challenge is it possible to express all the numbers from 1 to 20 just using subtraction, multiplication, the 4 and the 5, and you can use, you know, each of them as often as you like, but they're the only keys you can use.
Yep.
So again, in the chat, 4s and 5s, subtract, multiply, which numbers from 1 to 20 can you get? And we'll see whether we can make them all.
Yeah. Thank you, Daniel, for kicking off the chat. Yeah, we do want to reiterate, we're not expecting you to wait to post until you found all of them. As you find a solution to one result, please do post. Thank you. We'll wait, we'll give you a bit longer.
Daniel got 2, which was the last one that I got last time.
Isn't that interesting?
Some people start using the plus sign, and you're not allowed to use the addition sign.
Good point. Good point. We've only got takeaway and multiplication.
Gotta keep an eye on this.
You do, and I hadn't noticed that. So thank you, Charlie. Yeah.
I only noticed it because I made the mistake earlier and you noticed it.
We'll give you another minute or so. So Charlie, we've got lots of calculations in the chat.
And I could have been filling in the sheet as everybody went along.
You could have done, but something's made you pause and not do that.
Okay. So one aspect of being resourceful, it seems to me, is about using what I know. Gattegno and Jeff Folks talks about, what do they talk about?
The powers, no.
No, about making a lot of use from a little.
Oh, yes, yes.
So using a little bit of effort and gaining a lot. Rather than think about 20 problems all individually, can we, because one of the resources is to do with noticing patterns or with being efficient or so I think, and somebody did do that in the chat, said, oh, I can do this, oh, and this and that.
So I can do this, yes.
So I mean, I'm going to have a go here at exemplifying what we could do, because then students, you know, we could then give them similar activities where instead of the 4 and the 5 not working, it could be other keys that don't work, and instead of the subtraction multiplication, we could have something else.
Absolutely.
But so, for example, I could start by saying I could do 4 times 5 is 20.
Yeah.
But then once I know that, I can subtract 5.
Yes.
And I can get 15.
Yeah.
And I can subtract another 5 and I can get 10.
Yes.
And I can subtract another 5 and I get 5. Or I could have subtracted 4s.
Right.
So from 20 I could subtract 4.
Yep.
And another 4.
Yep.
And another 4. And another 4. And that is like making, you know, making a lot from a little.
This feels very efficient.
Yes.
Yes.
So what else could I have done?
Well, what about if you did 5 take away 4 to get 1?
Yes. Yes, except I'm not sure
you want to do
how
something.
much I'm going to use it. I don't know how whether I'm going to be able to make a lot of use of it.
Okay.
But I made a lot of use of 20.
Yes.
And I'm thinking, if I do 5 times 5, I get 25.
That's too big, but...
So I'm going to put 5 times 5 is 25 here.
Yes.
Because I'm going to make use of that.
Yes.
And then if I go down in 4s, I'm not going to hit 20, I'm going to hit 21.
There's no point in going down in 5s because I'm just going to hit the numbers that you've already got, the multiples of 5.
Now I know I haven't been asked to do 21,
no,
but I know I can do 21.
Yes.
Because I've subtracted. And then I can keep subtracting 4s.
Yes.
And I think that's going to be 17, and then 13, and then 9, and then, okay, then 5, and then, I get my 1.
Ah, nice.
Yes, because 25 minus 24. So 25 minus lots of 4. And so, and I could carry on doing that, this kind of thing.
Yes.
And having a starting point that I can build on then gives me a chance of, and I'm just trying to think, I kind of work out how to get...
well, I'm going to go back to my 1s, because now what I would do is do 5 take away 4 and get 19, get 14, get 11, get 7, get 3, because I could take 1 from all of those. And then I could take 1 away from those, and I would get my...
So how would you get 19?
I would do 4 times 5.
Yes, it's 20.
Take away 5, take away 4.
So you...
Sorry, no. I would do 4 times 5, take away, and then, oh no, but I haven't got brackets.
You haven't got brackets. But otherwise, yes.
Nice.
Yes. So...
Yeah, that hadn't occurred to me.
Okay.
That's really nice.
Yeah.
Yeah.
But I seem to remember...
Okay.
Doing...
Maybe somebody is... Oh, okay. Yeah.
Okay, the principle is here.
Absolutely.
That there may be ways of using something and then making it.
Yeah.
And it seems to me that is a resource.
Yes. Absolutely.
Knowing that you don't have to do this is a sort of being strategic.
Yeah.
Feels something that mathematicians do.
Absolutely.
And I want to encourage students to appreciate the value of being strategic. And in our guidance, we've sometimes said something about standing back and not rushing in too soon.
That's right. And so the role of the teacher is to explicitly talk about this as a way of working. Earlier we were just chatting and we were saying how sometimes when we work with students, we would make a point of drawing attention to a behaviour and saying, this is what a mathematician might do or might say or might think. And so the teacher's role is to specifically draw attention to those ways.
Yes.
Okay. Go on. I can just keep to carry on.
Okay, so I realised that one thing that we haven't done is, for example, used the 5 key and written 55.
Yes.
Okay, so we were always working with single digits. So I might do 55, take away 4, and take away 4, and I don't know. So that'll take me to I don't know,
47. Is it?
47.
Yeah.
And if I take 4.
39. No.
Sorry, let me just do that. Then everyone can see what I'm getting. 55 minus 4 minus 4 is 47.
Yeah.
And 47 minus 4 is going to be
39.
How much?
Then taking another 2 4s, you get 39. So that's 43.
Okay,
yeah.
And now I notice that 43, from 43, I can get to 18 by taking lots of 5s.
Nice.
So if
You're thinking about 3 8 3 8 3 8.
Every time I take 5, so I'm going to be able to do 18.
Yeah, good.
And I'm looking, I can do 13 and 8. Oh, but I'm going to be able to do 3 by taking away lots more 5s. So, okay. Nice. And I might be able to do something with 44 or with 45 and with 54 and then take away. I think we've got a problem on the NRICH site called what numbers can... Oh, no. I don't know. Okay. Not no.
And so there are interactivities available. We don't have anything quite like this on NRICH, but again, such a powerful idea that you can introduce. So that's the idea of building in a constraint, and then as you very eloquently described, Charlie, students are drawing on what they can do, but here we're encouraging that getting a lot from a little. I think, Charlie, we should go on to look at another task on the NRICH website.
Okay.
Sorry,
Now,
did you want to say something?
Yes, but so for those of you who don't know, we've got mapping documents.
Yes, that's right.
And we've got lots of problems linked to the curriculum. And I think the last 3 problems we want to show you are all on the primary mapping document.
That's exactly right. So I'm going to go, let me just share again, but this time I'm going to share the screen again. Here we go. And so here's the article that we were looking at. If we go right to the top of the page, I'm going to go to the easiest thing to do, I think, here is to go to the homepage, just so that for those of you not so familiar with NRICH, this is the homepage. And as a primary teacher, I would suggest your first port of call is the primary teacher landing page. And to find the curriculum mapping document, which is where we've linked NRICH tasks to curriculum objectives, as you might expect, you'd follow this box here. And here is the link. So the first task we're going to share with you is a really accessible task, and it's linked to addition and subtraction. So if I just scroll down here, you can see that the strands from the curriculum are along the top here. Addition and subtraction, and it's a year 2 task, and I think it's linked right at the bottom here. Yes, it's in fact, it's the very last problem. And this is called heads and feet. So Charlie, why don't we have a little think about this together? Here we go. We've got some hens and some sheep on a farm. We're being told that there are 8 heads and 22 feet, and we're being invited to suggest how many hens there were. So I wonder, shall we share a piece of paper and have a little scribble?
Okay, I'll write
so
down.
8 heads, 22 feet. If you wouldn't mind writing that down at the top of your piece of paper. Now, Charlie and I are going to have a little play with this. Of course, you might want to have a little think yourself. But I'm just now going to go and share the camera again. Here we go. Hopefully you can see this. Okay, thank you, Charlie. Now, I might, have a little go and try something out. But actually, going back to what you said before, Charlie, a resourceful learner, I think in this situation, might draw on working systematically as a resource. And so a sort of a starting point then, when I'm working systematically, what I might do first is think about an extreme. So I've got 8 heads.
Okay.
And I think I'd quite like to just draw 8 heads. Thanks, Charlie, for drawing my 8 heads. What I love about this problem is that it really encourages children to use their own recording to suit them.
With some hair.
That's really confusing. 8 heads with some hair. Were you thinking that sheep had hair or that hens had hair? I'm quite intrigued.
I'll get rid of the hair. That wasn't a good idea. We'll go back to 8 heads. Shaven heads.
As I was saying, is I might start at an extreme. So let's imagine that I've got all hens. So Charlie, if we had all hens, I think what I would do is I would draw 2 legs on each of those. Yeah, lovely. And so I know that if I've got 8 hens, I'm going to have in total 8 lots of 2, 16 feet. Now that clearly is not enough. I'm being told I've got 22. So clearly I'm going to have some sheep. Now, what I might do now is I might gradually build up the number of hens into sheep. So I think what I might do is I might start at one end, and instead I'd add 2 more legs to my...
So we've got 16.
So far we've got 16.
And now we've got 18. Now we've got 20.
Yep.
And now we've got 22. And I better stop there.
Fantastic. So I think on my farm, I have got 3 hens. That's 3 sheep.
3 sheep.
Thank you. 3 sheep.
And the rest are hens.
And the rest are hens. So, so I think now, of course, initially, children, we wouldn't necessarily expect children to approach it exactly like this.
Yeah, we'd be very happy for them to do some trial and error, work randomly and so on.
Absolutely.
But a valuable resource is to learn to work systematically.
Yeah.
And having worked on the problem, a conversation about how do people get at the answer? Yeah. And especially if the teacher notices that a student has approached it in this way.
Exactly.
And of course, you chose to start with 8 heads, and I might have started with 22 feet and drawn pairs of feet.
Okay.
So I don't know.
So, yeah,
so I might have done 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 feet. And then I know I've got 8 heads. So 1, 2, 3, 4, 5, 6, 7, 8. And I've got some feet left over.
Bodies. So you're going to have to join those up somehow.
Yeah, so I'll put those there and those there and those there.
Nice.
And then I've got my sheep, sorry, my hens and my sheep. So there isn't just one way of doing it.
Exactly.
But both are equally systematic.
That's right.
And being able to work like this is a resource.
Exactly.
I don't want to think of the only resources are my knowledge about place value or my knowledge about how to add fractions. Actually, working systematically is a capability that I want to harness.
That's right. Okay, let's go back to the mapping document and have a look at another problem. This time, we're going to look at the measurement section of mapping document. So let's go back. So here we go. Here's that heads and feet problem. If I go back, I'm back to mapping document. I'm going to scroll up to the top and choose measurements. Okay, and I'm looking for measuring and calculating, and this time I think it's year 5 we're going to have a little look at. Yes, year 5. So here's another task, through the window. Now, we're aware that actually on the screen, the image is a little bit difficult to see the grid lines. So what we've done is we've printed off the sheet, which is linked at the top of the page, so you can do exactly the same as us. And so actually, rather than working from the screen, I think I'm going to go and share the sheet that we've printed. And I'm aware we haven't got too long left, so I think this might be our last problem we have a little look at. Right, here we go. So here is the sheet. Let's just set up the problem. So what we've got here are some windows. And the local DIY shop, it calculates the price of windows according to the area of glass and the length of the frame of each window. And our challenge is to work out how they have arrived at the prices of the windows below. So I wonder, so Charlie, one of the things that, well, I wonder actually, before we say any more, let's give you 30 seconds to have a little think about what you might do to start. We're not expecting you to have got a full answer, but what might you do to start this problem? If you could post in the chat, that'd be super helpful.
So a lot of people are talking about working out the areas and the perimeters of the shape. And because the grid lines are very faint, what we've done is made it clearer by putting the dimensions of all the rectangles on another sheet. And that is a resourceful thing to do. You're drawing, you're making it clearer.
You're saving yourself, it's efficient as well, isn't it? You're saving yourself time counting each time you look at the picture.
And I think I'm going to label the rectangles so that when people are talking about them, they can refer to the different rectangles.
Yes, Daniel, you have suggested that you're obviously thinking about how the cost has been arrived at. Yeah.
Yes, and it's dependent on the amount of wood or something that's been used for the frame plus the amount of glass. Are there any are there any windows that make this task easier?
If we had worked out the area and perimeter of each one, and perhaps we would make a table.
So somebody's talked about A and C. They haven't said this, but I think they might have chosen A and C because both have got the same amount of framework. Both have got perimeters of 12. So the only difference in the price must be because of the amount of glass. Right. So A and C
are
really nice because both have got areas of 12. Sorry, perimeters of 12.
Perimeters of 12, but they differ in area by 1.
Perimeter equals 12 and perimeter equals 12. And so the difference in price must be because one's got an area of 9 and one's got an area of 8. Okay.
Fantastic. And so
let's, just like with a broken calculator, let's assume you can't have A and C.
Yeah, we're putting the constraints.
You can use A and something else or C and something else, but you cannot use A and C together in the way that...
Okay.
Somebody's mentioned D and F. D and F.
So D and F.
Oh, both have got perimeters of 20.
10 and 10. They have indeed.
These can be combined. And we're rushing a little bit here.
Yes, we are.
I would want students, I might say to students, draw attention to two windows that you'd like to use. Can the rest of the class work out why this is a good pair to use?
How would you use these two?
We used to share a common room where 2 of our colleagues used to do the crossword. And when one of them had solved a clue, they wouldn't tell their partner what the answer was. They would say, oh, I've got the answer to 14 across, or to 7 down.
Look at this one next.
Yes.
Yeah.
So again, so the perimeters are equal. So that's a good reason.
Nice.
Are there anywhere where the same area? Oh.
Yes, I think we've had a...
F.
B, F and E.
Wow.
B and E. So B.
Yeah, B, F and E have all got areas of 24. So actually, we've been given a lot more information than we needed.
A lot of choice here. So one of the what's the word I'm looking for? Characteristics of this task, let's say, is that element of choice. So if I'm not being told exactly how to go about the problem, I've got all this information to choose from, I am having to be resourceful. I'm having to, sift through the information I'm being given and justify my choices. But also, it's, as you said, Charlie, sorry, it's a lovely example of somewhere where you can involve students in figuring out each other's the link between shapes. Yes, nice.
But I can also start thinking, if I randomly choose 2 rectangles, can you work out the price?
Yes.
Are there some pairs that make it impossible?
Yep.
Or
we might always be able to do it.
I mean, so we've used all of them. We've used A and C. We've used B, F and E. We've used D and F. It does, could we have used E and C, for example?
Yes.
Or is that something we only ask secondary students to do when they do simultaneous equations? But this is a preparation for work on simultaneous equations for secondary students, because you get 2 equations with 2 unknowns and then you solve it. So this is wonderful in terms of preparation for what students will encounter after primary.
Exactly.
But we've possibly run out of time.
I think we have run out of time. So I think
stop sharing.
Yeah, I'm going to stop sharing the visualizer and instead.
People don't mind seeing us again.
I'm going to go back now to the webpage. And let me just show you, so we've done sort of a whistle-stop tour through some tasks to exemplify, what you might do to help children become more resourceful. So if you, sorry.
Teachers primary.
Okay. If I go to teachers and primary, and then I go to developing positive attitudes, and just scroll down a little bit, you can see this being resourceful link. And at the top here, you've got a link to the guidance that we have created. I'll just click on it now to show you what we've done in a similar way to other guidance we've created. We've set it out in sort of 3 sections. We've set out the values and ethos, what you believe about mathematics and mathematics teaching and learning that informs the way that you are teaching and learning in your classroom, you're helping students. Then we've got some structural considerations, so the way that you might orchestrate your lessons, if you like. And then some questions. This is about the nitty-gritty of the classroom interactions, which encourage students to become more resourceful. Now, by the end of tomorrow, what we will also have at the end of this guidance page is a link to the tasks we've used today in this afternoon's webinar, plus a few others that are particularly good examples. And we will also link to some secondary examples as well. But let me just go back. We will also put in some further reading for you as well. If I go back to the Being Resourceful page, though, I just want to draw your attention as well to the fact that we've got groups of resources that lend themselves to helping students become more resourceful, and they are linked according to year group. So that's resources that are linked to the particular curriculum objective in that year. So we hope that you found this afternoon's webinar useful. Charlie has put a link to the feedback form in the chat, which we'd really appreciate you filling in. What I haven't said, and I should do now, is that we're very fortunate that Trinity College fund these webinars, and of course it's really useful to us to give to be able to feed back to Trinity, and for us to be able to do a better job. You may be interested to know that our next primary webinar is on the 17th of June, which is also a Tuesday, and then we're going to be focusing on being resilient. Thank you very much. Thank you for your participation. That makes our lives a lot easier. We hope to see you again. Bye for now.